All right, this is ProffieOS4 Crash Course Lesson 6. So this will be primarily on functions, but the way that this has been built up, you definitely will have wanted to watch the previous 5 lessons. I know there's a lot there, but each one of these is intended to build on each other. So I'm going to cover several functions and several uses for them, but this is kind of, again, tip of the iceberg. There's just so much that it's going to take a number of different lessons to get through all of this, but each one kind of builds up on it. So in the previous couple of lessons, we've talked about shapes and functions. So this will be kind of using shapes and functions together to do other things. So again, if you haven't seen the previous video, some of what I'm going to go over might be new. Definitely check out the other ones first, otherwise it might be harder to keep in line. So with what I've got set up right now is just a blue blade. So everything, again, is layers in OS4. So it's got a blue blade, and then we're using an alpha layer. And again, in the previous episode, the alpha layer as well as mix, they take a color or colors, and then they also take a function. So functions, not only are functions able to set up, like in this case using bump, they can set up portions of the blade to do things. So in this case here, we've got a bump with the value, so the location center of the bump is at 16,384, which is center. Again, we go over, I'll bring this up. If you're 0, 16,384 is in the middle, 32,768 is the tip, and then also for size of stuff, it's going to be the 50% would be 16,384. So for what we have here, the middle of the blade is the 16,384, and here it doesn't have the second value, but the width is also set to 16,384. So now you can actually, within a function, you can use other functions, and that's what the main focus is going to be. So the first one I want to cover is actually how to use, essentially set up like a rotating animation. And this is meant to be kind of a starting point. And there's a number of ways that styles that already do this. But if I wanted to kind of start getting into how to use functions to really do some cool stuff, I needed to kind of start here. So this is like the first step. So some people might have already played with this. If you haven't played with this before, it's still going to be a fun thing to do. So what we're going to do is, the bump being a shape, within the shape, it's taking, so the bump is a function, but within the function, it can take other functions. So right now, it's just taking a solid int value of 16,384, which again is middle of the blade for the location. I can change this into another function to do something with that. So what I'm going to do is I'm going to take this, I'm going to go into functions, and I'm going to grab the sign. All right. And what sign is it's going to go, essentially sign is going to go from, in this case, it's going to go from 0, or here, the lower, to the upper continuously, like a sine curve. So it's going to go from 0 up to 32,768, and then it's going to come down from 32,768 back to 0. So it's a back and forth. So what you're seeing on the screen is obviously the value percentage. So 0 being black, and then when it's full white, that's the 32,768. Within a bump, though, because the bump position is using this, it's going to move the bump. Now, the revolutions per minute is speed, so I'm going to leave it all like this, and I'm going to go back up. What you're going to see is that red bump is now moving from the hilt to the tip, and it's going to keep going back and forth. Now, this is very similar to the Cylon effect, but if you wanted to set something up, obviously I think Knight Rider, I'm that old, but you can see that the sign gives you now an animation. So I have an alpha layer with a bump in it, but now I've added this animation. So now you can set sign up. Now, if I wanted to, I can also speed it up. So the revolutions per minute is here. So let's triple that speed. We're going to hit submit and then go back and look. And now obviously it's much faster. So you can adjust the speed of the animation. And then what we've got now is we're going to have it moving back and forth. Now it's moving right now, hilt to tip. You can set your limits on that. So again, knowing your values. So let's set it to only move 50% of the blade. So we're going to move this, and I'm just going to use rounded numbers just to give me a little bit of leeway. You can obviously do your own calculation out, and we'll set the upper limit to be about 20. 20. Set that. So now it's going to restrict that movement. And what sine is it's going to be always moving. So it will not stop moving at any point in time. It just gives you that. So obviously you might not want this specifically on your blade. There's a lot of other uses, but sine is one of those functions. If you were looking to do your own kind of animations, you can apply, and you want to apply this to a shape. Now, if I apply sine to something else, so say I actually apply it to an alpha layer. So this is using the sine function within the function of bump. I'm going to open a new window just so I can keep that, because I want to get back to that actually. And I'm just typing this in because it's quicker for me to type. So that was just a shortcut. So right now I've set up a different way. So I've done an alpha layer again of red, but this time I've just set the function as just the int 16 through 84, and again that's 50%. So that means that it's a 50% with alpha layer. It means 50% opacity. So that means that you're seeing some red in here. So if I change this down to 0, you will not see it. So now there's no red, it's gone blank. And then if I up this to the full value of 32,768, what I'll get is actually a red blade. So anywhere between 0 and 32,768 is how much the red shows, how much opacity in that red layer. And again, going back to the previous lessons, always the base layer gets covered over by everything after it. So this is blue as the base. So by setting the alpha layer of red at full value, that means 100% red takes over blue. So it doesn't matter. Now, again, the other version, instead of having a set value, we set a bump. And that bump has size that applies. And then because I put the sine in, it's actually moving. So now, and we'll get back to this in a minute. So now I can also use sine here, so just within the alpha layer. And what it's going to do in this case, and we'll speed this up a little, so revolutions per minute is the speed. Now, what you're going to see is a blade that goes, and essentially now some of these are done by other styles. So there are going to be styles, so this would be similar to the pulse style, but it gives you another option to set it up in that it's going to go from blue to red, and it's using the sine function to go from 0% opacity on red to 100% opacity on red. So it gives you that fading effect. So again, a lot of these functions are already used in other places for full styles, but this is kind of, again, building blocks to get to the next level. So this may not be groundbreaking, but it's another way to do it using functions. And as you understand the functions, it gives you that flexibility to start creating some other stuff. So now that's using just the straight sine value applied to the layer. Oops, I clicked on that. So there we so that's to use it to change up colors. So now another way we can do this with sine, that's kind of another cool function, and I'm going to just keep opening new windows just to get to here, is I can actually do a mix. And mix and alpha layer are similar, except mix has 2 colors or more. So the default here is going to always have the 2, but let's do a 3rd color and submit it. All right, so now with mix, the order of the template's different. So this has the function in the beginning. So I'm going to grab this function, and I am going to use sine. And we'll keep it at 10. So now what's going to happen is as it goes through, you're going to see it go through, in this case, red, blue, and green. It's going to keep changing at that rotation speed through the values, because for what this means is at 0, when the sine gets to 0, it's going to be a red blade. When sine is at 16,384, it's going to be a blue blade. And when it gets to 32,768, it's going to be the green blade. and it's transitioning, so 0, blah, blah, blah. So it's changing the mix of these three colors. That's how you're getting from red to blue to green, and then you're going backwards. So sine goes, it doesn't loop, it goes backwards. So it goes up and down, up and down. So you're getting the red mixing with blue to full blue, the blue mixing with green to full green, and then the green going backwards. So sine goes back and forth. So that's why you don't see a transition from green to red with this. So this gives you kind of another way to have a blade that's changing its color the whole time, is using that sine function. And then the last one, and I'm going to, because mix is pretty straightforward, I'm going to actually do something in here. There is another function in here that we use. Actually, I'm sorry, it's, where is it? Style. There it is, rotate, it's under styles. I thought it was under function. So with rotate colors X, you can also have the ability to have the colors rotate. And what it is where, again, you'll see it's actually in the template itself, the sign. This, by setting, what's going to happen is rotate colors X is, it's the function that actually does the color wheel. And you can use, you'll see in my styles in the library, I use rotate colors X with the variation. The variation is color change. That's what that essentially translates to. But you can take rotate colors X, you can use that color wheel functionality and just have it always rotate by putting that sign in place here. Now, if I put variation into that in place in that function, this color changes only after I go into color change mode and I turn my hilt. If you want to make a blade that's just always going through all the colors possible, that's when you use the sign. And what it does is it's going to go through at the speed you set, so 10, and it's going to just always rotate through all the colors. So if you wanted to animate rotate colors and get all the colors in your blade, and this is what I use on the Omni blade style in the library, it lets you get all the colors mixed in, and it's just going to always rotate. And you can change the speed of that, and you don't have to spell out, you just pick a starting color. That's the other thing about it. You can actually build color sequence with a list of colors, but if you want to use the function to accomplish actually all the colors, you would do it with the sign in rotate colors, and then we'll slow it down. Oops, that sped it up. I want to go the other way. Slow it down to 5, right? Yeah, that makes sense. Just thinking backwards there. Now it'll slow down. So now it'll go slower through your colors. And you can really slow it down to 1 revolution per minute because there's so many colors in there. So if we take this down even further. So now you're going to get all your colors. So again, just another use of that sign function. So having sign with the ability to go up to 32,768, back to 0, up to 32,768, add a revolution just gives you the ability to have all these changes continuously happening. And again, we're applying it, rotate colors for colors. We can do it in the alpha layer or mix to have the color itself changing. So in this case, just using alpha layer, it's only dealing with red and blue, blue being the base, and then red's going from 0% to 100%. If you wanted to, you could actually stack multiple layers as well. And then, of course, using positional within the shape. Now, another thing we can do too is obviously I can also set that here. So let's set, we'll just drop it in at that. So I can also do it for width. So you're going to see the width of that bump rotating through its size, and it's going to 0. That's why it zeroes out, and then it's going full, which is 32,768. So you're going to see that happening while it's moving. So you can use functions together inside of other functions. So I'm getting the bump, its position is running on a sine at 30 revolutions per minute. Its width is also running on a sine at 10 revolutions per minute, and this is kind of the effect. So combining these functions inside of each other and using them in conjunction with each other just gives you a lot more possibilities. I mean, you can really design some cool stuff. But so sine is a good one to kind of start out with. Now, I'm going to step into, we're going to start talking the responsive stuff. And this is, hopefully, we've built up to this point. If not, I do have a lot more we can do with responsive. So I'm going to cover I'm only going to cover 2 right now. There's a lot of other stuff that comes with this that'll probably end up being another video, just because of making it more bite size and more manageable. So I've got my bump here. I'm going to change this back just to a straight int. We'll set it at just a nice round number for now. And I'm going to take this back to just an int. And we'll put this back in the middle. So like that. So now I've got my bump again. And again, this is maybe a very simplistic approach, but the idea is to kind of build upon this. So I was just showing how I can animate stuff with sine. And I can animate either of these values because they're functions. Anywhere there's a function, you can put a different function in its place. Now, certain functions won't work together. It's a little bit of trial and error, but also if you understand what the function's doing, it comes together. So if you're messing around and you put something and it doesn't work, some of these things contradict each other and some of them just don't calculate together type of thing. So a little bit of it is kind of trial and error and see what it happens. But now what we're going to do next is we just showed sine. I can actually take this bump and apply a responsive control to it. And the 2 responsive controls we're going to cover are the twist angle and blade angle. So here, instead of the bump's position being fixed again, we saw what happens when we apply sine to it. If we apply, we'll start with blade angle. And we'll leave basically you want to leave these values for now. You can change these. It will affect what happens, but for starting out, there's actually a few other ways to do that, so we'll build upon that. So this is only kind of dipping our toe in the water with blade angle and with twist angle, because there's actually a lot more to be done with them. But there's other functions that have to kind of get covered before we get to putting all this together. So this is step 1, so it'll be simple, but we'll build upon it. All right, so now what I have here is within the editor, and I've said this in previous videos, what the editor is doing is it's emulating the blade angle control, but it's doing it using sine visually. So it's going to keep moving back and forth. The reality is, though, when you actually have this loaded, this number only changes when you change your blade angle. That's what makes it a responsive control. So when you're watching it in an editor, either blade angle or twist angle, and this also applies to the battery level one, which I did a little bit on that in a different video. We'll get back to that one also. It's going to show you constant movement. The movement itself, this is just how the best way Frederick was able to get it to show, because obviously we don't change blade angle here or twist angle. So this animation, it's not actually an animation that's going to happen when you apply blade angle. When you apply blade angle as a function to something, it's going to, in real time, respond responsive control to what you're doing with your saber. So blade angle, if it's pointing straight up with blade angle, it will be set to 32,768. If it's pointing straight down, it will be set to 0, and you have that whole range. So that comes in here. So down is going to be 0, up is 32,768, and then anywhere in between is going to give you that other value. So when the blade is horizontal, horizontal, technically it's going to be 16,384. So this function acts the same, but it responds to the blade angle. So this is what gives a lot of the responsive capabilities now, is this function as well as the twist angle function. So now, if you loaded this style up in this form, this red dot, and this is actually one of the ones I did in my proof of concept, this red dot will move as you move your blade. And again, you can also restrict where it's moving. Oh no, wait. Restriction is a completely different function. These values, that's right, these values are something different. So for starting out, you're going to use blade angle as is. You're going to do just with the brackets. You're not going to put anything in here. If you change these values, they're different. They're not restricting. They're for a different purpose, and that'll be another lesson. So to start out, if you wanted to have blade angle just moving from hilt to tip, it responds. So when your blade, so on this style, if you load, that's where I was getting to. When you load this style up, if If you point your saber straight up, the red dot would be at your tip. If you point it straight down, it would be at your hilt. And then as you move in between, it's going to move at the speed you're moving it. So it also doesn't have a speed on it. So it's, again, real-time responsive. So if you're moving your blade quickly, up and down, straight up, straight down, it's going to move that quickly. If you're moving it very slowly, it's going to be a slow movement. And that's what gives that realism, particularly for localized lockup, as well as some of the other controls. But that's what is happening with blade angle. So I'm using, in this case, the blade angle to control the position of this bump. So where the location of that bump is. And then you can do exactly the same with twist angle. So twist angle, blade angle, different control, very similar uses, or very similar outcomes. So in this case, instead of it being reliant on the angle of your blade, twist angle is basically the z-axis. So as you turn your hilt, you're going to actually see that bump move up and down that hilt. And then so it'd be kind of like this. So you get that, again, this is only showing it back and forth. If it's really on your blade, it's going to respond in real time to how you turn that hilt. So you can set either blade angle or twist angle there. And then we can also apply blade angle. Let's apply it on this. And what will happen is, so sine is going to always go back and forth. Say I wanted to have my blade be blue if it's pointing down, and red if it's pointing up, and purple if it's horizontal. I would put blade angle in here. And you're going to see it again. It's going to go through the cycle. But what's going to happen, and again, the speed is dependent upon what you're actually doing. This alpha layer, when it's pointing down, is going to be 0, which means you'd have a blue blade if you're pointing down. When you start to move that blade up, it's going to start turning blue. So you get to blue being the full when it's pointing straight up. And this gives you the ability to change the color by blade angle. So your blade, at all times as you're moving it, is going to always be changing color. And you can combine a lot of different colors and effects to do that. But this is using the blade angle with the alpha layer to change. Again, blade angle is going to go from 0 to 32,768. What that means in terms of the alpha layer is it's going from a 0% to 100% opacity. And then again, twist angle is essentially interchangeable there. It's just a different control. So if you had this version, it wouldn't matter on the angle of your blade, but as you turn that hilt, it's going to go from blue to red and mixes in between. So it gives you the control. So twist angle is the control that works on melt. So that's how you get the melt effect, where it goes from red to a yellow, or depending on the base blade you pick. In my library, sometimes it'll be a dark orange to a yellow to mix with other colors. But that's how you get that change in the melt effect, is using twist angle to actually use the alpha layer's opacity, or in some cases it's using the mix, but the same difference. So you can use twist angle to get that accomplished. And then the last piece is going to be in actually rotate colors. You could do it as well. So you could set it for twist angle or blade angle and use that rotate colors capability. Same exact concept. In this case, but one difference. So if you set rotate colors X with the rotation twist angle, it's not actually color change. If you want color change where it'll hold that color, you would actually do rotate colors X with the variation. Variation is what makes color change possible. By setting rotate colors X with twist angle, your blade is essentially always going to depend on the angle of that turning of the hilt, or if you use blade angle. So it's an omnicolor result from my library, just with the control being blade angle or twist angle. But it's never, it doesn't stop at a color. If you put variation in here, you actually would go into color change mode, turn the hilt to get to a color, lock it in, and then the blade would always stay that color. So hopefully that makes sense. So rotate colors X, depending on the function you put in there, will act very differently. Sine would go through all the colors all the time. Twist angle would go through the colors as you turn your hilt. Blade angle would change the color as you angle your blade. And then variation is what couples with the color change functionality to allow you to actually change the color of your blade and keep it that way. So just different uses, but putting these functions in is what makes that happen. So those are three of the main kind of starting points with using sine, blade angle, and twist angle. And then, oh, there was one I kind of missed, so bear with me. I want to also, actually, we're going to change it here. So I'm going to change this. I'm going to change this to smooth step because this is another use of it. And I'm going to, so let's see. So this has signs in it already when I do smooth step. So I'm changing the alpha layer to be a smooth step. So smooth step changes, yeah, it's got a sign in it. So I'm going to take this. I want to show smooth step as it is. Let's put it at the hilt. Sorry, I just looked at my notes and remembered I wanted to cover this. And we will set you, let's set you at an int. And we're going to set you, so smooth step again from previous videos on shapes. Smooth step, if you put a negative number for the length or the step width, it reverses it. So when you want to put something at your hilt side, you're going to use a negative number. So I'm going to use negative, we'll say 10,000. Again, just picking a round number. So what we're going to get here now, actually, let's pump this up. Oh, that's why it's set at 0. You want to move away from your hilt a little. So now what I've got is, this is, and this is in the responsive emitter effects in the library. This is how you would do them. So you'd set your base layer, you set an alpha layer, and then you use smooth step. In this case, I'm setting a smooth step to create this, basically an emitter effect in red. And then you can, if you wanted to make it so that your emitter, the size of that emitter effect changes based on blade angle or twist angle, which is what I use in the library for that effect, you would swap out one of these ints. So I've got my smooth step here. So let's say if you move the position, it's going to keep that fade the same. It's going to slide up and down the blade. So let's go, what we'll do here is we will do, and for practical purposes, again, the limiting of blade angle and twist angle is kind of important with responsive stuff. So this is, again, starting point. So, so a lot of you'll see if you go into the library and you use some of these responsive things, there's going to be a lot of other functions all wrapped together. But I'm breaking it down bite-sized pieces to get to that point. So if you take the styles from my library and actually broke them down, you're going to see a lot more in there function-wise than just this. But if I just trying to put this together so that I can make it into these lessons, if I dump that all down, first of all, I'd probably be on a billion tangents and you guys wouldn't follow, but I also just think it's too much data. It's just too much information dump. So this is going to look a lot different end result, but this is the start point to get to it. So that's where I'm trying to get at. So I'm going to change the position to blade angle, and I'm going to view this layer. And what's going to happen is that emitter effect is going to slowly slide up until it overtakes the whole blade. Now, if for my emitter effects, I do put the limits on it, again, the limiting with blade angle and twist angle is actually a little more complicated than with sine. So that'll be a future update or a future lesson. But now what would happen with this one is that smooth step's position is going to move up and down the blade angle wise. So again, it's moving animation wise just back and forth, but this would respond to your blade angle. So if you have your blade sticking straight up, it would be that full red value. If you have it sticking straight down, it would be almost none. You'd have just that little fade area, which now I'm getting to the tip. When it gets back down here, you'll see it. And if I'm horizontal, it would be about halfway up the blade with the fade. And that fade is set here at the step width. You can also, again, interchange it so that it's your twist angle, and that lets you twist control. And again, it's going to react as you're turning your hilt. So turning your hilt, you're going to see that red overtake the blue. Turning it back the other way, you're going to see the blue come back. So this gives you that control. And again, it's always the responsive twist angle, blade angle is always real time. So it's what you're doing with your blade is actually what's going to happen. It's not an animation like this. So you get that ability. And then you can also apply it to the step. So the step is the fade area of smooth step. So if I freeze this again, let's change it back to an int, and we'll put it back. We'll just put it at 4,000 again. So with smooth step, just kind of a rehash, this was covered in shapes. The position is the start of where this fade or step width is. So you'll see that it's a step width of 10,000. What that means is that fade from where it's fully red to fully blue is set at 10,000. And again, it's based on 0 to 32,768. If I drop this down, and again, the negative is what turns it from hilt out. If it was a positive number, actually, I'll just show it. So if I change this to a positive number, what you're going to get is a red tip. So the red is going this way, it starts at 4,000, and then it does its fade this way. But by having it negative, it puts it at the emitter. And then if I change this size down, if you take it really small, you'll see it's almost a hard edge, and obviously 0 would be, so 0 would be a hard edge, but it would flip it. And again, just this was covered in the shapes, but if I did this, you'll get a hard edge right here, but it's going to flip. If I want to do, so obviously you can't have -0. If you want to flip it, you just do -1. If you want an absolute hard edge, and that creates that effect. And then if you wanted to, so say I wanted to have this, I can actually do the same thing with width. I can set it to BladeAngle, submit it, and that, oops, oh, all right, it'll work from the tip because you can't go negative with BladeAngle. That's where those other functions come into play. So it's actually not going to be all that visible because it's all the way here. So I'd have to move this out. Let's move it up so you can see it better. So it'll turn that fade area back and forth. It's not as visible as I'd like, but you'll see that red getting more prominent and less prominent as it slides to this spot. And there it is, and then it's going to go back. So yeah, all right. So for the step part of smooth step using BladeAngle, TwistAngle, we do need those other functions to really get to that spot. So we'll omit that for now. So put that on the side. We'll come back to that one. And then, we can do, actually, yeah, let's just cover one more. I'm going to change this alpha layer. Actually, let's just go here. I'm going to pick a style. Let's do, it's a good one. Do stripes. All right. So I'm gonna set this up. I should have had this set earlier, but let's set up stripes to be something better. Oh, way too fast. That's not what I wanted. Okay, so I probably should have started with this. So hopefully you're still following. Within the styles themselves, and this is not applicable to everyone, so you'll have to do a little bit of research on your part within the .h files. If you don't know what I'm talking about there, this is like let's call this a precursor to a future lesson, just because I realized I got through my points a little quickly. So any style, so Rotate Colors X has it. Any of the styles that have an X version, and again, not all of them have it. If they have an X version, you can apply the X, but then that makes any numeric value in it a function. So turning this into the X version of stripes is the exact same thing. The difference now, though, is that this speed and so the width and the speed now being functions within the X version of stripes, X being the variable version of stripes. And again, if this is getting over your head, I'm going to come back to this in the future. I wasn't planning on this in this lesson, but I'm going to show it for those of you who are already kind of following where I'm trying to get to and want to jump ahead. I can now make it so that I can control the speed of my stripes with BladeAngle. And that's going to be some craziness, and it's going to slow itself down. Again, you'll want the limits on this, so this is, again, kind of putting a bookmark in, but you'll see it'll slow down to 0, and then this would be based on BladeAngle. I can also change this to TwistAngle. The preview is going to be really weird on this because there's no limiters on it. So it's going from 0 to 32,768 back and forth, and 32,768 in terms of speed for stripes is what's doing here. 0 is going to freeze it. So we do need to get to the lesson about putting the limits on TwistAngle, BladeAngle before this is really good. But if you want to play, you can turn, so again, not all styles. Certain styles will let you use their X value, and it is in the, so you get into the styles folder of your OS, you go into the .h of each one of these. If you see the X version, what that means is it'll take the function. The normal version, so just stripes doesn't take functions. Just stripe takes a numerical value for these two. But if you have the X version and you use the X version, you can drop functions in. Being able to drop functions in, actually, let's do this. We can just have it so that this will be maybe a little better because sign lets me control it better. So let's do sign to show what I mean. Just again, starting point, precursor. So what will happen here is that stripe speed is going to go from 0 to 3,000 and back, up and down, up and down. So for stripes, you can set it using stripes X to be a function control. And for those of you who are not able to jump ahead and put the limits on TwistAngle, BladeAngle, which we will get to, sine would work. Obviously, sine just always rotating itself through based on the revolution speed, but it gives you the ability to limit here. But when we get to the BladeAngle, TwistAngle with the limits, you can actually use that for stripes and all these other ones that have the X. So that's what I wanted to get to, is that functions aren't just for alpha layer and mix. The functions are actually able to be applied anywhere that you see the X's. Now, again, certain styles, because like fire, a few of these are just so complex they can't take functions. And it's more just, there's already so much going on that if you dropped a function there, it probably just wouldn't run. But a lot of these will have the X version in their .h. They're not promoted here. They do work in the editor, but they're not listed out here just because what they actually are is they're what runs that style. So it's a function that runs that style, but instead of you putting a function in, it just takes a fixed number and runs it as an int. And if you read the .h files, you'd see it. But because they're accessible by applying the X, you can then change those guys to be controlled by sine, BladeAngle, TwistAngle, and then a few of the other functions that we're going to get to. But so this is what I mean, tip of the iceberg stuff, is that there's so much that we can delve into with all of these functions. And as we get more into limiting those responsive controls, there's a lot we're going to be able to do. So hopefully I didn't confuse you guys by going into the X a little too early. Hopefully you're following along. If this is confusing to you, just hold on to this thought, maybe bookmark it in your brain, and hopefully, I think the next lesson I'm going to get back to this. The next lesson I'm going to start talking about how to limit BladeAngle and TwistAngle, and then I'll touch on this once again, and then all the uses of the X stuff will probably be 2 lessons away, if memory serves. So hopefully help somebody out. Definitely play around with the editor. Again, the editor is in beta. I'm pretty sure Frederick's going to move it live any day now. It's been fully tested out, but he's got a lot going on. But you can access the editor, style editor beta, or it's also my library. If you go into the customize enhance screen and choose any of the styles, build them out, and click check in editor, it's going to the editor beta, so you can play with them. But just go in and play around, load these styles up as you build them, see what they do on the blade. Because like I said, particularly the TwistAngle, BladeAngle stuff, the editor is just showing you an animation. That isn't what's going to happen. What's going to happen on your real blade is it's going to react in real time to what you're doing, either blade angle or twist angle. So to really play with blade angle and twist angle, you definitely want them on your saber. But you can start playing with those. Again, the limiting stuff, which makes a lot of the more complicated responsive controls, I'm going to do the next lesson on that stuff, so that you can take that and do more with them. So without having controls on what's happening with blade angle and twist angle, they are going to, in some cases, look a lot different than what the library stuff does. If you're able to decipher the stuff in the library, then definitely go off and play with it. If you're not, I am going to get around to those functions. But hopefully this helps teach a little bit more. Hopefully I didn't confuse too much stuff. Probably better if I stick with the script only. But thanks, and hope you all enjoy.